In this tutorial, our learning objective is to talk about the surface area and the volume of a sphere, another three-dimensional object, okay? So let's talk about a circle first because the concept of a sphere are somewhat related to understanding the concepts of a circle, okay? So a circle is an object in two-dimensional plane that if you define a center, any point on a two-dimensional plane, let's say that center is the O, right? And if you define a boundary around that center such that if you take a distance at any point on this boundary from the center, it will be at equal distance. And that distance is called the radius, correct? Now, if you extend your imagination a little bit, that instead of staying in a two-dimensional plane, let's say now you are in a three-dimensional space, okay? And if you take a point in space, in three-dimensional space, and then you create a surface in three-dimensional space around that point, then that object will be called a sphere. The property of a sphere is that if you connect any point on the surface of this three-dimensional solid and you connect it to the center, then all of those points will be at equal distance from the center, and that is called the radius of a sphere, okay? And the unique property of a sphere is that just like a circle, it has only a curved surface in three dimensions around that point. It has no sides, no vertices, no edges. So this is what is known as a sphere, okay? And whenever we discuss or learn about three-dimensional objects, we always want to talk about the surface area, that is the total surface area and the lateral surface area, because these are the two surface area. We will always have to find the clarity or the differences between them, right? Now, in the case of a sphere, we say that the lateral surface area is obtained by a formula 4 pi r square. But we know that the unique property of a sphere is that it has no edges, no sides, right? That means the surface area we observe around the center is also the total surface area. And these two areas are identical, right? So we say that for a sphere, the total surface area is equal to the lateral surface area, and they both are obtained by a formula 4 pi r square, right? And likewise, we will say that the volume of a sphere is by a formula 4 by 3 pi r cube. In both of these formulas, we are stating that r is the radius of a sphere. So continuing your imagination, now stretch your imagination a little bit more and let's talk about what is a hemisphere, okay? So let's do this. Let's take a sphere, a three-dimensional solid, okay? And divide that sphere into two parts using a two-dimensional plane such that it passes through the center, right? Then what you will obtain is really the two halves of that ball, right? And then each of these objects that you obtain as a result of bisecting a sphere is what is called a hemisphere, okay? Now, as you obtain a hemisphere, then you will notice that now we have two different areas. One area is this curved surface area, which is all around the center in three dimensions, right? And then another area you will notice is that this is the area that you will obtain as a base of this hemisphere. So that will tell us that a hemisphere will have two components when we talk about the surface area. One is the lateral surface area, and that surface area will not be equal to the total surface area because now you also have a base that is circle in shape, right? So that will be the second part, what will be known as a circular base. Now you notice that hemisphere is nothing but one half of a sphere, correct? That means my lateral surface area will simply be one half of the lateral surface area for a sphere, right? So it will be one half of 4 pi square, or it will be equal to 2 pi r square, right? Where r is the radius. And what is the total surface area then? The total will be, of course, a combination of 1 plus 2, combination of lateral plus the circular base. Lateral we already have calculated, it is 2 pi r square, and the area of this circular base will be pi r square, and that will be 3 pi r square, correct? Now this is the only difference you are going to notice, that in the case of a hemisphere, the lateral surface area is not the same as the total surface area because of this additional base that we have, right? So then let's talk about the volume. Volume would be easy to calculate. It will be simply one half of the volume of a sphere, right? And that will be one half of 4 by 3 pi r cube, and that can be equal to 2 over 3 pi r cube. Okay, now we have all the formulas that we need for a sphere and for a hemisphere. Let's take a look at two examples to understand the application of these formulas a little better. All right. So in my very first example, we have that the surface area of a sphere is given as 5544 centimeter square. Find its diameter. Okay. Now we know that the surface area is equal to 4 pi r square, and that is equal to 5544 in centimeter square. Okay. So let's substitute the value of pi, and what you obtain is 4 times 22 over 7 times r square is equal to 5544. And then what you can do is you can say that r square is equal to 5544 times 7 divided by 22 times 4. Now you have a simple case of multiplication and division. And then if you take the square root on both sides of this equation, you will find that r is equal to 5544 times 7 divided by 22 times 4 and a square root of that. When you solve this, you will obtain that r is equal to 21. Okay. Now you have a simple case. You have obtained the radius. That means the diameter for this sphere will be equal to twice of radius, which will be 2 times 21 or 42 centimeter. Okay. Very simple to apply, and this is what your solution is. Okay. Take a look at the second problem now. Okay. This was problem 1, and now you are at second problem. If the radius of a sphere is doubled, what will be the ratio of the volume of the first sphere to that of the second sphere? So let's say the radius of sphere 1 is r1 and the radius of sphere 2 is r2. Okay. And likewise, volume is equal to 4 by 3 pi r1 cube, and the volume of a second sphere will be 4 by 3 pi r2, which is the radius of the second sphere, and it's in cube. Okay. Our interest is in finding the ratio of the volumes of the first sphere to that of the second. So we need to obtain this ratio, which is V1 over V2, right? So when you substitute these values respectively, you will find that the V1 over V2 is equal to 4 by 3 pi R1 cube divided by 4 by 3 pi R2 cube. Okay. We will cancel out the common factors in the numerator and denominator, and what you obtain is a ratio of two radiuses, right? R1 cube divided by R2 cube. Okay. Now pay attention to the condition that you have been given in the very beginning. The condition is if the radius of a sphere is double, that means the second sphere, we are saying that the second sphere radius is equal to twice of the radius of sphere 1, right? We are going to simply substitute this condition in this expression, and then what you obtain is this ratio is equal to R1 cube divided by 2R1, and this is in cube, entire value 2R1, right? So when you expand this, you will obtain that this is equal to R1 cube divided by the cube of 2 will be 8, and it will be R1 cube. Now you can cancel out the like terms in the numerator and denominator, and what you obtain is a ratio of 1 to 8. Simple enough, right? So this is your answer in this case. The ratio of volume 1 to volume 2 will be of 1 by 8. This is your final answer. All right, so keeping that in mind with the reference of these two examples and the learning that we had about the sphere and the hemisphere, our objective was to understand what is the total and lateral surface area for a sphere and what is the expression for the volume, and also we learned about the same for a hemisphere as well.